We just spend a lot of time talking about heat specifically, of one substance or two substances that reach the same temperature, how to find the heat, the temperature, specific heat, etc. Looking a little bit more specifically at work. Specific pressure volume work. So pressure volume work occurs when the force is caused by a volume change against an external pressure. So think of a balloon. A balloon's volume increases against an external pressure from the outside. The volume expands on the inside. Another good example is an automobile engine. So in an automobile engine, the combustion of gasoline causes gases within the cylinders to expand, pushing the piston outward and ultimately moving the wheels of the car. We've defined work so far that it's the force acting through a distance. W is equal to F times D. Now, when the volume of a cylinder increases, it pushes against an external force. Because there's always a force pushing on, as it expands, it's pushing against that force that's counteracting it. The external force is called PXT, which is defined as the force divided by area, which then we look at this equation. So we define the pressure as force over an area, or the force as the pressure externally times a specific area. The distance through which the force acts as the change in the height of the piston as it moves through the expansion is the change in h. Then we say that the volume of the cylinder is the area of its base times its height. So first we then plug in for our original work. We say, all right, well, instead of saying force, we can say the force is the pressure externally times the area. And the distance is the change in the height. The volume of the cylinder is the area of its base times its height, which is A times delta H, which then gives us work is equal to external pressure times a change in volume. As the volume of the cylinder increases, work is done on the system by the surroundings. Work is done on the surroundings by the system as the volume of the cylinder increases, if you look at the picture down here. Therefore, work has to be negative. Since upon expansion, when something expanding, that means the second volume, is larger than the first, so your change in volume has to be positive. So therefore, if the change in volume is positive, but the work has to be negative for a positive expansion, we need to add a negative sign to the equation. Work caused by an expansion of a volume is the negative of the pressure that the volume expands against multiplied by the change in volume that occurs during an expansion. So you see here all those equations kind of being put together. We have that height and volume is equal to the height change by the pressure and the area, which we say is the volume, that is then multiplied to the external pressure to give us work. So putting that into practice, how much work is required to expand the volume of a pump from 0 liters to 2.5 liters against an external pressure of 1.1 atm? So work is defined as the external pressure times a change in volume. So it would be 1.1 atm times my change in volume, which is 2.5 liters times 0.0 liters, which gives me that the work is negative 278.6 joules. Now, not joules. I went a little ahead. 1.1 times 2.5 is negative 2.75 liters atm. We want work in joules or kilojoules. So we need to figure out the conversion to go from liter atm to joule. So first thinking, okay, how much work is required to expand the volume of a pump from 0 to 2.5 liters against an external pressure? So we have the change in volume and we have external pressure. So you multiply together and you get work. Now we need work to be in joules. So the conversion is that 1 liter ATM is equal to 101.325 joules. So then you take negative 2.75 liters ATM times the conversion factor, and you get negative 280 joules as the answer and the amount of work that is being done.